So here we're doing more examples of substitution. Again, the process is exactly the same. We're going to identify u, it's usually the inside function. We find du dx and solve for dx. Substitute in for u and dx, everything should cancel out. We integrate with respect to u, back substitute, and don't forget your plus c. We're going to have a few more issues on these types of problems. They're a little bit different, but I'll show you how to do it. Let's get through them. It says find the integral of the square root of 1 minus 2x. And then that's with respect to x. So here, why can't we just directly integrate? Well, we can't integrate because it's not just x raised to some power. It's something else raised to that power. So again, we're going to let u be the inside function here. The inside function here is 1 minus 2x. So try out u equals 1 minus 2x. Again, we take the derivative of u with respect to x, would then be the derivative of 1 minus 2x, which is negative 2. We solve for dx on this one. Again, multiply both sides by dx, divide both sides by negative 2. You would end up with dx equals, du over negative 2. We now know what dx is. We also know what u is. So we go back into our original function and we rewrite it in terms of u. So this is the integral of, instead of the square root of 1 minus 2x, this is really going to be the square root of u. And then instead of dx, I have du over negative 2, making my substitutions. Well, notice I have a negative 2. That's just a constant multiple, so I need to pull it out in front. I want to be really careful, though. I have to keep that 2 in the denominator. So really what I'm pulling out is a negative 1/2. It is not a negative 2. It is a negative 1/2 that I pull out. This would be u raised to the 1/2 power with respect to u. Now I go ahead and I integrate using the power rule. I keep that constant, that negative 1/2. I need to integrate u to the 1/2. Well, that would be u to the 1/2 plus 1. Again, 1/2 plus 1 is 3/2. If that's raised to the 3/2 power, then I need to divide it by the exact same power. So I'd need to divide it by 3/2. But remember, when you divide by a fraction, that's the same thing as multiplying by the reciprocal. So instead of dividing it by 3/2, I'm going to multiply it by 2/3. Multiplying by 2/3 is the same thing as dividing by 3/2. And then I have the plus c. Notice my 2's are going to simplify here, so I can do a little bit of cleaning up. I'd have a negative 1/3 times u to the 3/2 plus c, but the issue with that is this is in terms of u. My original problem's in terms of x's. So I go ahead and I back substitute. I'm ending up with negative 1/3. Instead of u, I have a 1 minus 2x. That quantity raised to the 3/2 plus c. Again, we could check our answer using the general power rule here, or the chain rule. The negative 1/3 and the 3/2 would cancel. That would give me my negative 1/2. Then I'd have 1 minus 2x raised to the 1/2. The derivative of 1 minus 2x is negative 2, which would simplify with the negative 1/2. So I'd end up with the square root of 1 minus 2x, which is the original problem. It works. Let's move on to example 7. Again, example 7, we're doing integration by substitution. I have the integral of x times the square root of x squared plus 4. I have a higher power of x that's also an inside function of x squared plus 4. So I'm going to let u equal x squared plus 4. I take the derivative of u with respect to x. Well, the derivative of x squared plus 4 is simply 2x. I go ahead and I multiply both sides by by dx. I divide both sides by 2x. I would end up with dx equals du over 2x. I know what dx is. I know what u is. So I go in and I rewrite my original problem. This would turn in the integral of x. This would be the square root of u times du over 2x. Notice those x's simplify. I have a 2 that I can pull out, but it is in the bottom, so this is 1/2 times the integral of u to the 1/2 du. So that's 1/2. Well, the integral of u to the 1/2 would be u to the 1/2 plus 1, which was 3/2, divided by 3/2. But instead of dividing it by 3/2, I'm going to multiply it by 2/3. 2 simplify on this one. And don't forget your plus c. So I have 1/3 u to the 3/2 plus c, which is 1/3 times back substitute for that u being x squared plus 4. So this would be x squared plus 4 raised to the 3/2 plus c. So my final answer is 1/3 times the quantity x squared plus 4 raised to the 3/2 plus c.